Hello and welcome to part 3 of the Java programming language course. In this course we will learn a bit about how to typecast, which means how to transform one data type into another. Basically we'll learn some how strings work, how switch statements, while loops, for loops, and that kind of thing. Okay, so let's start. So what is typecasting first of all, right? So if we go inside our main function after we print the sum of two numbers we just did in the previous tutorial, we will go here and we will, for example, as you may remember, we have different types of variables, okay, of primitive integer variables. A very common variable is the int, okay, to store an integer. So I will call this my number, okay. If I set this to, for example, 8, right, and now for some reason my program needs double precision calculation, so I want to transform this int into a double, right? So I'll go and say double my double, right? And what I will set this will be to my number, right? So what I'm doing here is basically casting, or kind of automatic casting, this number, this integer, into a double, okay? So now we will print both results. So after here we're gonna say system dot print ln, oh sorry, a system dot out dot print ln, and this parameter will pass my number, okay? And after we assign that into my double, you're gonna do the same. So you're gonna go system dot out dot print ln, and I'll pass my double, right? Okay, so now I'll open the terminal, I will compile the program and I will run it. And as you can see, we have here, of course, these 6 remain from the previous tutorial. And this tutorial we have first our 8 and then 8.0. So we didn't have to do anything to transform this integer into a double. We just put it inside a double and it was transformed. So this is called automatic casting, right? So why does it happen? Well, because the integer is a smaller data type than a double. So, for example, an integer usually occupies 4 bytes and a double usually occupies 8 bytes. So there's no problem when when storing something small in a big box, right? Because it doesn't matter that it is some empty space on the box, right? But what happens when the opposite happens, right? Imagine we have a byte, and I'll call it my byte, and I will set it to 9. And imagine I want to well, actually the opposite, right? So I want to put the number inside my byte. So the previous number was 8, so maybe we can go and say 800, right? And in the byte, what happens if I put my number here, right? If I put my number here, it's saying fit 4 bytes inside 1 byte, which is kind of strange, right? So we will see what happens when we try to print this to the console. So system.out.println my byte. Okay, so now that I want to print it, it says error. It doesn't even compile, so it says incompatible types, possible lossy conversion from int to byte, right? So what we have to do here is a manual cast, and we have to say get and try to fit the significant thing or the part that fits on the byte, and the rest is just discarded because there's no place to fit it, right? So to cast my number, we will put we'll open a parenthesis before it, and inside the parenthesis we will type the new type of this variable. In this case, it will be a byte, right? Okay, so now we will compile it again, and now it's compiled, as you can see, but now we will run it, and as you can see, it says 32. So why it says 32 if I'm putting 800? Well, because of the binary notation, right? So because of the binary notation, we're getting 32 and not the actual value we want. Okay, so now let's test with 80, for example. If int is 80, let's see what happens. And we still get the 80 here. Why? Because the byte is actually able to store an 80. So a byte is able to store values up to 127. So I will put the integer to 127, and it is still displayed. But what if I go one more? If I go to 128, right? So I'm going beyond the limits of a byte. And if I go beyond the limits of byte, I can see that it basically goes to negative 128, because that's how negative numbers are represented here, right? So what happens if we go to 256, for example, right? If we go and say 256 and we compile it, it says 0, right? Because it kind of doesn't fit it, and so we have this strange behavior, right? Which can be worked out, really, if you kind of do the math in paper. So this is how we cast into a different type of data type, right? So if the receiver data type is larger than the incoming data type, then it's an automatic cast. Otherwise, we have to make a manual cast, as we did here with casting these to bytes. So we're basically saying convert or transform this number to a byte, even if some information is lost in the process, right? So this is basically how we cast. We have already learned how operations work, right? So, which was really easy, you know, basic operations. And we also used strings previously. So here, when we set the dog name, we are passing a string right here. So what is a string? Well, the string is a data type that holds text. If we want to define a string with a name, for example, let's say string my name, and I will open double quotes and I will type whatever I want. For example, Max, right? So if my name was Max, I will type Max or whatever my name is, right? So, and we can also use and get the string length, right? So how can we get the string length? Okay, so we will print the string length right here. For that, we're gonna say system that, oops. So system that out dot print ln, and what we'll pass will be my name. If we want to know how long is the string, we're gonna say my name dot length, right? Which is an integer. We'll return an integer. And here, if we want to display more than one thing, we can concatenate two strings by writing double quotes. And for example, I will type my name length is, okay, and I'll put an addition sign to add the rest of it. So we now will compile the code and then run it. And as you can see, my name length is 3, right? Because Max has 3 letters, right? So very easy way to find the string, the length of string, right? So that's how we we create and get the length of a string, and maybe we can also do some operations on strings, right? For example, we want to get some of the string, a part of it, right? So what if I want to get a part of it? So I'll type my name, which is the name of my string. Then I'll say that substring, which means create a substring. And if we tell it a begin index, it will cut everything that comes before that index. For example, if I pass the number 1, it will go to position 1, which is A. So remember, we start from 0. So position 0 will be M. Position 1 will be A, in this case, of max. And we'll only print AX without M, because we're creating a new string by getting a part of the current string, right? So let's compile the code and run. And as you can see, only AX is printed. So that's it when we kind of want the last part of the string. But what if we want a middle part? For example, I'll say my something larger. My name is Max, right? So if we want, for example, to get something in the middle, for example, name is something in the middle, and we will do the following. So M is 0, I is 1, the space is 2, N is 3. So we'll pass the first one, which is 3, and then a comma, and on the second one we will pass the end index. So in this case, it was 3, 4, 5, 6, 7, 8, 9. So you're gonna pass 9, and we will compile and run. And as you can see, it says name I. Oh, well, actually it's 10 here, right? So I counted wrong. So if I do it with 10, it says just name is. So what we're doing here is we're cutting the string and getting the part that is on the center in this case, right? So this is basically a cool string operation of how to make, how to get a substring, right? Okay, so there's also some math functions in the Java programming language, right? So let me delete these and create some math well, I won't delete the main method, so I will delete this method and I will delete the contents inside the main method. And inside the main method, we can find something kind of useful, which would be the math library. For example, the max value library. So, for example, if I call math, if I press dot, I can see all the methods I can call from math. As you can see, lots of mathematical functions right here, okay, which is great. Okay, but for example, the max library right here, it says max A and B. So as an A and B, I will pass 4 and 8, for example, right? So these will return basically the max number. So you can say int max equals math max, okay? And then we will print the result or the value that's stored in max by saying system.out.print ln, and we'll pass the max. Okay, and now we will compile the code, and now we will run the code, and as you can see, it returns 8 because max is 8. So that's how max works, pretty simple. Now the min function can also be used. You will say, but I can't tell. But sometimes procedurally, if you have a large algorithm, then this can become very useful. So now the min, which will return the minimum number, which is in this case 4, okay? So pretty simple. So we can also get the square root of a number, right? So for example, if we want to get the square root of 8, I can use again the my library, and instead of min, I will say sqrt to get the square root of 8. And since the square root may be a double, I won't use an int right here, so I will use maybe a double, okay? And I will change from max to square root Okay, so I can print the square root right here, so square root. Okay, if I compile this and run it, as you can see, here we have the square root of 8 with double precision, right? Which is 2.82 and so on, right? So that's a square root. What else do we have? Here? Okay. Let me see. So we have already learned a bit of math functions. These are kind of the most basic ones. Of course, you can have lots of more mathematical functions. You can find this library and any other library. Now let's talk a bit about control flow, right? So control flow are the if statements basically. If we say if a condition is met, for example, square root is less than 3, then do something. Then print system.out print ln, and for example we'll print square root is less than 3. So this is what we call control flow. If a condition is met, then do something, and else, which means if it's not met, then do something else. For example, in this case, system that out that print ln, and I will print square root is not less than 3, right? So if we go here and compile the code and then run it, we can say that it says square root is less than 3 because it actually is. But what happens if we change here from 8 to 9? Okay, of course the square root of 9 is actually 3, so if we compile this and run, we say the square root is not less than 3, which is equal in this case, right? So this is how control flow works. But we can also do something else, like right here. Instead of else, we can also put else if. So we're checking if an additional condition is met. So if it's not less than 3, we will check if it's 3. So I'm going to say if a square root equals 3, right? And if it equals 3, and we will say square root is 3, okay? And if this is not 3 and not less than 3, then it must be more than 3 or greater than 3, right? We're gonna say system.out.print ln, okay, and we will say square root is greater than 3, okay? So if we go back and compile this, square root is 3, then it says square root is 3. Now if we go and put here an 8, for example, so the square root of 8 will be, the square root of 8 will be less than 3, so I'm going to compile it. So this is how we test that the program works. So it says square root is less than 3. Okay, and if I put 16, of course the square root of 16 is 4, so we'll check if that works. And it says square root is greater than 3. So this is basically how can we use this. We can say, we can use less than, greater than, equal, different, as I told you in one of the previous tutorials, right? So this is basically how the control flow operations work in the Java programming language. Now, instead of doing lots of ifs, we can do something differently, right? We can do something using switch, right? So you're gonna switch, for example, an integer, right? Or a double or something. So you're gonna type switch. So what switch does is kind of a lots of if and else if statement, right? So we will switch the variable. So the variable that we want to switch in this case is the square root variable. So we'll say square root, right? Okay, so we open brackets here, and inside these we will say case 1 dot 0. Okay, so what does it mean? Well, this means in case the square root is 1 dot 0, we will do something, right? So we say case 1 dot 0, we do something and then we will break. What break means? Well, basically means we're done it and we don't have to keep checking for something else. So then we're gonna, if it's not 1 dot 0, we will check case 2 dot 0, okay? And we will also break, right? And this is how we kind of do this. And we can also have the default case, which is, well, default, as the name says. So just press default, and we have it. And we don't really have to break here because default is the last element here. So that's it. So in the case it's 1 dot 0, what you're gonna say is system dot out dot print ln, and I'll print it is 1 dot 0, right? Okay, and in the case it's 2 dot 0, I can say system dot out dot print ln, and I'll say it is 2 dot 0, right? So, and in the default case, you're gonna say system dot out dot print ln, and we'll set this to default case, right? Whatever the case it is. Okay, so if we compile this program, we have an error right here from double to int. Okay, so what are we going here? Okay. So maybe we have to specify this to floats. Will that fix this? So let me check. Let me check. Let me check. Okay. To make our lives easier, we will switch an integer, right? So here we're going to say int, and I'll say int to be switched. Anyway, the integer is the most common variable, right? So, and here we're going to say case 1 and case 2. We don't need these f's anymore. And we will say it is 1, and here we'll say it is 2. Okay, let's make this faster, right? Okay, if we go and compile this, and then we run it, so we have incompatible type, possible load. Oh, we don't have to switch square root, we have to switch int to be switched. Sorry, I forgot it. Okay, now, if I compile this, it compiles, and if I run it, it runs and it says default case. Why it says default case? Well, because it is not 1 and it's not 0. So every number that is not 1 or 0, I mean, it's not 1 or 2, it will say default case. So if here I put the 1, okay, and I will compile the code and run it again, then it says it is 1. The same thing with the 2. If I put a 2 here, if I compile the code and I run the code again, it says it is 2. So this is how the switch statement works, which works very similarly that the if, else, and statements are also control flow operators that enables us to control the flow of the program, right? So that's it for control flows. Now let's maybe introduce you to while loops, okay? So which are the most basic loops we can make? Okay, so let me delete this to clean it a bit more. And to create a while loop, we just type while. Okay, while we open parentheses and then we open brackets. And inside these parentheses, what we will do is we will check for an state, okay? For example, I will say integer loop count. I will set it to 0, and I will say while loop count is less than 10, okay? Then we will print, so I can say system that out that print ln, and we will print loop count. Okay, and we have to update the loop count variable. So we're going to say loop count plus plus. So now let me explain what is this doing. Well, first of all, it is checking that loop count stays below 0, and while loop count stays below 0, we will print the current loop count. So it will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then these will increase the 9 to 10. And here we will check that 10 is not less than 10, and the while loop will end, right? And we'll stop printing anything else, right? So if we compile the code and we run the code, we can see exactly what I told you. So it prints 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Because it is printing everything that is less than 10, okay? So it says everything that is less than 10, what to do? Well, print it, okay? So this is the most basic and most simple while loop. We also have the do while loop. So what's the do while loop? So let me delete this while loop. The do while loop is as follows. We're going to say do, we will open brackets, and after we end the brackets, we say while loop count is less than 10, right? So how is this different from the previous while loop? Well, the do while loop is kind of different. It's kind of a variant of the while loop. Okay, so this loop will execute this code and once, and then we'll check for the condition. Okay, so in the previous one, it first was checking the condition and then executing the code if the condition was met. So here it will execute the code at least once, right? Even if the condition is or not met, and for the next conditions, it will check if the condition is true, then do it again, right? So basically, I will print it again to see how it differs from the previously. I'm going to say system.out.print ln print line. I will print loop count. Okay. Okay, so if I compile this and I run it, oh, we forgot to update. So it's printing zeros because we haven't updated the loop count. So we're gonna say loop count plus plus. So we have to update it, right? So now that we have updated it, I'll run, and as you can see, we have the same. But how is this different? Well, because it will print the first one even if loop count is not less than 0. It's not less than 10. For example, if I set loop count to 100, and if I compile the code and I run it, it will still print 100, right? Because it will print regardless of the condition for the first time. Then it will check the condition and will print again only if the condition is met. So this is do while loop, right? Great, so this is also kind of very used. Now we will introduce the for loop, which will be the last loop we will learn. So how does a for loop works? Well, a for loop is more elegant maybe. We don't need an external variable. We can create a counter inside the for loop. How can we do it? Well, we say for. We open parentheses and we write int I equals 0. So I'm defining the variable, the counter, which was the previously loop count. So for convenience, I can also call this loop count if you want. So loop count 0, and I then type a semicolon. Then I'll check the condition. So I'll say loop count less than 10, and another semicolon, and I'll say loop count plus plus. Oops, loop count plus plus. So as you can see, it is way more elegant than the previous way, right? So it is way more elegant. So the first thing we define is the first statement, then the second statement, and then the third statement, right? So basically that is how this works. So now let's print it right here. We're gonna say system.out.println, and I will print loop count. Okay, so if I go and compile the code, I can see that I am printing the loop count, right? Which is awesome. So this is the recommended way, or the most used way, because it's self-explanatory. But again, it depends really on the use case you need. So that is the for loop, and the last thing we will learn, the last loop, is a variation of the for loop, which is called a for each loop. Okay, for example, this works maybe when we have an array, so I'm gonna call it char array, my array, and I'll set this to new array, new char. So we're creating a new char array, and here I specify the size, for example 10 characters, right? And here I will say for. Okay, so this is why this is called for each. So I'll say for each element of this array do something. Okay, for example, if instead of defining these, we can also, so this is a way of defining the array, we can also define it manually by open brackets, like saying first character will be A, the second will be B, second will be B, and the third will be C, right? So that's how we define an array manually. So the for each will be for char I, for example, and then we press colon, and we say my array, okay, and we will do something. We will print system.out.println, okay, and we will print I, right? Okay, what is this saying is print every character on my array. Okay, so if we compile this and run it, it says A, B, C. So we have learned while loops, do while, for loops, and for each loops, and that's basically about the loops. So that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye.